Let me start the recording. Okay. No worries, Ranjit, but make sure that you finish by end of this week. Otherwise, the assignment is going to pile up, and you may not enjoy it that much. All right, all right, great. So, so everybody is clear about what is a combiner and what kind of functions can be the combiner. If you have any doubt, just let me know, because the same phenomena of same kind of combiner function is going to be reused in future sessions in Apache Spark, for example. The reduce function of Apache Spark is like that of a combiner. All right. So Sushant's point is that a little bit of high level recap. Here it is. So we talked about in the last session. Okay, okay. So in the last session, what we had done is we first had the problem discussions, whatever we did earlier. Okay, and then we dive deep into into something called not this, not this. These are to be moved. All right. Then we showed how to write the map reduce in Java. Okay, and made it run, how to write a test case. All right. And then we talked about input splits. Input split is something which a logical representation of data to the MapReduce. Input split is part of MapReduce, not HDFS. Okay. HDFS, the blocks are hard boundaries, byte by byte slices, but the input split is a logical representation of the data for a MapReduce. And you can switch the input split for a particular for your problem. Okay, say for example, if you want to process like your input in key value format, then you can use a key value text input format, and so on. Okay, if you have binary data, you can use sequence file input format, and a lot. Okay, then we talked about data flow in case of a single reducer, multiple reducers, and then we discussed a little bit about combiner functions and partitioners. Okay, with partitioner, you are able to divide the data by your choice between multiple reduces. Okay, multiple reducers. Okay, and with the help of combiner, you are able to further combine the data on the mapper node itself before it gets sent to the reducer. All right. Then, all right. So today I'm going to discuss something called data locality optimization. All right. So So there are multiple ways of doing data locality. Multiple systems have multiple kinds of behavior. Out of that, there are two main ways. One is by the way of pre-configuration. Okay, so a question from Seema is input split is defined by size or number of lines. Input split is generally defined by something logical, and it could be also defined by size if you wish. It all depends on which input splitter are you using. Okay, okay. So input split is basically a logical way to get the data. Okay, it can be number, it can be in its input splits definition might include the data size or number of lines. Okay, so did I get your question, Seema? Yes. So logical size can be different. Yes, you are right. It can be different, and therefore there will be a slight movement of the data from one block to another, or one node to another, from one block to the other block, and to create a logical input split. All right. So there are basically two ways to do the data locality. One is predefined way. Okay, we define a topology. Okay, and a second is by the way of pinging. Okay, this is automatic. So while Hadoop prefers this mechanism, other some of the other systems such as MongoDB, they prefer the way of pinging. Okay, so how do systems know each other? How would name node know that which node is closer and which node is farther? Okay, so you can do it by the way of pinging also. If name node keeps on pinging all the nodes, then and all the nodes keep on pinging each other, so they know the proximity of each other. So this is one mechanism which MongoDB use. Okay, not Hadoop. While this is what is being used by Hadoop. Okay, so here we are going to talk about that kind of mechanism. So imagine that you have a okay, okay. So imagine that we have a data center. It has got three racks: rack 1, rack 2, and rack 3. Yes, you're right, Seema. MongoDB has self-discovery while Hadoop is done by the user, right? So you have a big data center. It has got three racks: rack 1, rack 2, rack 3. On each rack, there are these many nodes. 3 plus 3. There are 8 nodes in this particular example. Now there could be multiple data centers also, and so the blue one is HDFS block, and the map task is this color. I don't know whether it's green or orange. Okay, so so basically the map task and the HDFS block, when the main tendency it to have this way. So whenever you submit a job and Hadoop decides to create map task out of it, its first intention would be to get your map task executed on the same machine on which an HDFS block is, right? So when you are submitting your job knows what data you are going to process, and accordingly, it will try to name node name node and yarn will try to figure out what is the closest you can get. Okay, so this is the first one is the best case scenario. Sec- second one is second one the B one is your hdfs block your hdfs block and the map task is on the same rack but on different machines. Okay, so now the communication between the two will happen over the switch. So each rack has got their own switch. Okay, a switch is like forming a common network locally, and then all those switches are connected in the data center. Okay, now in the worst case scenario, in the third priority would be that it schedules the map task on different rack altogether, and the worst would be the map task is on different data center, and and the HDFS block is on different data center. That will be the worst case scenario, the fourth one. Now here here what we are trying to do basically is uh, it will try its best for the first case. In case this particular machine is very busy doing something else, then it will try to execute it on this different node, and then if that is also not possible, then it will try to find another rack and then try to schedule it. Now the question is that it does not it does not detect the distance between the racks, and it doesn't consider that. Okay, so a task here, my a block here might get the rack here or here, it's same for it. Okay, so the distance between the racks do not matter to it, as well as the distance between the machines do not matter to it. Okay, so the only unit of distance is the topology. Okay, so Susan's question is, when you say map task, is it the application master or the container? So it is your map reduce job task when it is going to get executed on application master, that task. Okay, so application master will be created on the node which is closest. Okay, all right. Now a quick question we have already talked about: can reducer take the benefit of data locality optimization? Okay. So could you just explain a little bit? Right. So it needs the data from different nodes for reducing, right? Which means that the data locality optimization, where we are trying to execute something on closer to the data, this data has to be, if it has to be combined with other one, then there has to be at least one form of transfer of the data. So effectively, a reducer cannot take the benefit of data locality optimization. No matter what, when a reducing happens, the data need to be transmitted to some other machine. And if you are lucky, your reducer might be, if you have a single map task, in those cases, then actually, if you have a single map task, then there is no point of map reduce, right? Okay, so this strategy keep on changing every now and then. All right. If you have to store a file with the replication factor, all the nodes will, okay, which all nodes, as in the with respect to topology, if you have to store a file with replication factor of 3, yes, on 3 different nodes, that is accepted. Two on the same data center, one in another. Okay, okay. So I'm expecting the answer in the format what Swati is answering. Okay, in if I understand correctly, one of the node might be in the same rack, while other may be in the entire data center. And the third one, so Seema? Okay, you are saying that okay, but other two will be okay. Yes. So this is for sure that first copy will be on the same node. So if you are on, say, you SSH onto Hadoop and you do SCP into Hadoop 1, the first copy is going to be on the same node, same data node. Or if the same data node is not running, same machine is not running a data node, then it will be on another one which is on the same rack. Okay, first it will try to keep the first copy closest, and the second copy also just next to it, and the third one somewhere else. Okay, first one will be on the local node, the other would be, other two would be off the rack. But this strategy is keeps on changing. This strategy keeps on changing. So never mind the question. Okay. Yes. So yeah. So we do not keep two copies of the data on a single node. We always keep, I mean, replication, the way when we define replication, all these three copies have to be on different nodes. Okay. All the three copies have to be on different nodes, because if a node fails, as you say that, if we put two copies of the data on the same node, then then all the two copies will get lost. So first copy will be on the same node and the other will be on the off the rack. But this strategy have changed. This is little old slide, so we will see. So user all, okay. Okay, Amit's question is it done automatically? Or, yeah. So user can configure Hadoop when they are setting it up. Okay, we'll talk about it. But you cannot define affinities for your MapReduce task. You cannot say no, 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 run it on this one only. And maybe they have provided it, but uh, I have not seen that option. Is it always one node per system? No, I didn't get. So okay, so Sahu's question is that can we run more than one node on one machine? Okay, and whenever we talk about a node, it's actually, data node is nothing but a process. Okay, you can run multiple processes, but but it will cause unnecessary complexities. First, it does not bring any additional benefit to you. Okay, so the way the system has been designed, that it reads a config from a same location. So if you are changing the port number there, then it will be unnecessary complexities. But if you really are adamant and you want to create more nodes per system, that is fairly possible. Okay, that is very much possible, but it does not make much of a difference. So it will be three nodes, but there is a configuration for two and three. No. So it will be on three nodes, but based on the topology, it will send to, first copy will be on the local node, and the second copy is going to be on the same rack but different node, and third copy is going to be on the off the rack. Okay, so this answer is wrong. This answer is wrong. Let me just mark it. Okay, and yeah, makes sense to you. Now moving on. Now the way a topology is defined, how does MapReduce, I mean, how does Hadoop compute the distance, is by the way of defining each node like a path. Okay, so like for example, you have got switch 1, rack 1, and then node 1. Okay, so we can say it like in the like file directory format, s1 slash r1 slash n1. Okay, that is how each node would be represented to Hadoop. Okay, and the distance between node 1 and node 2 will be computed based on the common ancestor's distance. So who is the common ancestor of node 1 and node 2? Rack 1, right? This is the rack 1 switch basically. So the distance between node 1 and the rack 1 switch is 1, node 2 and rack 1 switch is 1. Therefore, the distance between node 1 and node 2 is 1 plus 1. So the way distance is computed when we talk about network topology is the summation of the distances of both the nodes from the common ancestor. For example, the distance between node 1 and node 4 is 1. Who is the common ancestor of node 1 and node 4? This one, right? And the distances of node 1 and rack 1 is 1, 2, 3, and 4. So if you start traversing from node 1 towards the common ancestor, then come back down, that is the distance. All right. So that is how the distance is computed. So the overall objective of running a MapReduce task is to have minimum distance between the two nodes. Okay. Okay. Now let me ask you again, what is the distance between node 5 and node 3? Okay, good. Good. All right. Let me answer Susan's question. But if you can s- if you say nodes can ping each other, wouldn't that be right? So when I was talking about nodes can ping each other, I was talking about MongoDB, which was where the distance was computed by pinging to each other. Okay, so that is another strategy altogether. That is somehow that has got benefits, but that has got also the problems with it. One is it chokes the network. There are already so much of heartbeat going around, so that chokes the network. Second, pings might be deceiving. Right. So yeah, Seema's question is, but in first few slides you mentioned that. So okay, here when we are talking about switch is not your name node. Okay, switch is not your name node. This is the hardware physical structure. Name node could be node 1, and data node could be node 2, node 3, node 4, node 5. All right. I'm sorry for the confusion. All right. All right. So now we have yeah. Amit's question is multi-zone setup doesn't make too much of sense in Hadoop. It does make sense when we are having multiple zones, as in you're talking about two data centers, right? So it does make sense because generally what you do is you generally keep a third copy on different data center. That's the general behavior of um, MapReduce, so that in case there's a fire in one of the data center, at least you have one copy over there. Okay, it does make sense. Okay, so multi-zone is having multiple data centers in different geographies. Okay. Now, so rack awareness is that again, whatever I have discussed, it's in a summary. It understands the network as a tree. Network is represented as a tree, unlike the general psyche that network is a graph. Here, it's a clear tree, and it's represented as a file path. There is something called DNS to switch mapping, which provides the translation, and there is a configuration key using which you can define this configuration key in your configuration file, and there you can specify that this is your script which is going to translate the input into out the IP into the path. Okay, the default, so basically your script will get as a argument, you'll have to write there's a default functionality, but you can also configure this one. So basically your script, whichever you want to use as the paths aggregator, will get an argument as IP as an argument, and then it has to give a path name. Okay, that is the role of this script, which is basically the configurator. So any IP it gets, it has to convert it into a path. The default one basically replaces dot with slash, and in the beginning it attaches a slash. Okay, you can see that. So you can basically configure your network using this script file name. You can write your Python program and put it there as a script file name, and then you can do this. All right. So any executable binary can be your script, IP to the IP to path name translator. All right. All right. So how? Okay. So, Julie, let's just go through this exercise. You will understand it by the end of it. So, the distance between slash D1 slash R1 slash node 1 is how much? The first one. The answer is 0 here. Okay. Because the common ancestor itself and the distance between itself is 0. Common ancestor of this D1, uh, below D1 you have R1, and below R1 you have node 1. Susant, agreeing? Okay. Now, and the second one, slash d1 slash r1 slash n1 and slash d1 r1 n1, what will be the distance? The answer would be 2. Okay, you can have a look here. Node 1 and node 2 is Amit. That's okay. Seema. And the third one, it's a different track. Yeah, 4. And this one, 6, right? Good, good. All right, same thing has been depicted in the graph below. If the block and the node are on the same line, its distance is 0. Then distance is 2, distance is 4, and distance is 6. Right? Good. So, in case you want to configure, you can put a variable here, this variable in HDFS. I- if you have a look at Hadoop one. All right, so my secondary name node is down. Space is down. All right, so all right, so you can basically add one more key and add the script file. Okay, path to your script. Okay, py or sh or php or whatever. Okay, so then that way you can add here. All right, the same data locality will be used by hdfs as well as our uh, yarn. Okay, now let's move on. Good, great. So now we have officially completed our basics of Hadoop. Okay, we will be moving on to pig and piglet latin. Okay, all right, so what exactly is pig and what exactly is pig latin, why do we use it, and how does it help in the real solutions. Okay, so we'll go into the details and then we will go into the language details. All right, so a pig is essentially a engine for executing data flows in parallel on Hadoop. Okay, so it basically lets you create the complete data flow which can be executed in parallel on Hadoop. But it's not limited only to Hadoop. They are working on porting onto multiple distributed systems. The language in which we control pig is pig Latin. We instruct pig using pig Latin. Pig is the engine, and pig Latin provides you operators similar to SQL, where like join, order by, filter, and group by, and so on. Okay, so again, what exactly is pig? Pig is basically something which takes your query. Remember, I'm talking about query, and converts it into internally map reduce tasks and get it executed on Hadoop. Okay, so it's like a smart developer which takes your question and converts it into map reduce and get it executed and gives you the result, right? Because there were problems with map reduce. First, you have to write everything in terms of maps and reduces. Okay, in the time when you have a brilliant query language like SQL, querying for data sounds really is writing programs, writing Java programs or any programs sounds very awkward. Okay, second, the map reduce phase is little difficult to comprehend for lots of us. Okay, therefore pig was written to fill this gap so that we can simply write our queries. We should be more bothered about problem we are solving rather than rather than writing code in our language. Okay. Having said that, this does not obsolete the need of learning MapReduce. Okay. Okay. So that was the easiest way I could describe to you the pig. That it is basically something which takes your query in this form and converts it into MapReduce under the hood and gives you the result. As you can see in this, it provides a syntax like this. It says load the line into input. You got input. After that, you break input into word by word using its query language. And then you group the words. After that, you iterate it and then you dump the counts. So as you can see that in few lines we have been able to successfully write the word count example. In case you do not understand this example, don't worry, because it was not planned that you will understand it. It was just to tell you that this is what you do with pig. Okay. So you basically think in terms of how do you group things, like you will start thinking as if you are working with SQL with the same mindset, and then you take one step at a time to reach the results. Okay. So it allows you describing how data flows. As you saw that the data flows from this text file into input. From input, we broke it down into words, then from word to groups, and then counts and so on. Okay. So we describe how is the data going to flow, how are we going to read the data, process the data, and we can also do various kinds of multiple outputs in parallel. I'll show you in future in further slides how can you do that. Okay. Now it provides you a complex workflows. It provides you a brilliant way of executing things. Lot of things have taken inspiration from pig. Most of the most of the distributed systems actually follow the strategy of pig. Even even our Apache Spark, some of the syntactical design is similar to pig in lot of sense. Okay. Now let's see this. So let's compare what does pig Latin brings to the table which MapReduce did not. Okay. Or let's just compare it one by one. Or okay. So pig Latin provides you the way SQL provided you, the join, filter, group by, order by, union, and MapReduce provides you using MapReduce provides operations such as group by and order by indirectly. Okay. By the way of creating maps and reduces, you do groups and order by, and the joins are creating joins in the table. You remember our fourth problem in fourth assignment? Doing even a simple join like that is pretty hard. Okay. That's the problem with the MapReduce. It requires even the a little good developers to write a decent, or even the basic query, basic joins query. Okay. Provides optimizations such are rebalancing the reducers and so on. Anyway, that is also possible using MapReduce. We can specify number of reducers and so on. Okay. And we will see how we can control the reducers, number of reducers using piglatin. Okay. Under it, piglatin understands your scripts and does the error checking and optimizations. So just like the way we have a SQL query, where if you try to insert a wrong data into wrong column, it gives you an error. Similarly, Or if you are trying to query some columns which are not there in the table, SQL gives you an error, right? Because SQL knows upfront about your data, right? So that is why even before it goes to the data, it can help you fix your script, fix your pigletin script before it starts querying the data. But MapReduce doesn't really know much about the data. It is all up to you how do you design it. Okay. Therefore, the code is fairly um, opaque. Okay. So that kind of error checking is will further require a lot of effort if you are doing MapReduce. And it's of course smaller code, so less effort would be going into maintaining the code. Okay. And I mean, now, the last point is more important. Last point is that Pig Latin has got some syntax, it has got some functions, but if you got to go beyond those functions or beyond that kind of strategy, then you might have to go for MapReduce. Okay, let's take a case. Let's take a case of Let's take a case of our four problems. All four problems could be reasonably well solved, except for DNA mirror image 1. All four problems can be solved with Pig Latin. The DNA one, for the DNA one, we can create something of the sort, something like a custom function for Pig Latin, and we'll be able to work. But what kind of problems are difficult to solve in Pig Latin? So uh, I had thought about something just now. Okay, I thought about something just now. So uh, there are many kind of problems which are easily solvable in MapReduce but are not solved using Pig Latin. Okay. Say say you are basically I was saying about something and then it slipped. Okay. So Seema's question is what if data is unstructured? So Pig Latin handles the unstructured data. So I'll show you a couple of examples where most of them Pigletin will work pretty well. Huh. I was talking about matrix multiplication in particular. So doing a matrix multiplication will be pretty difficult to code it in Pigletin, but it will be easier to do it in MapReduce. All right. So matrix multiplication is one such case. You also think about it. If you can do it better in Pigletin after this session, I mean it'll be great. Okay. So answer to Seema's question, no, you don't. The data doesn't need to be structured. And same is true for Abhinav's question. All right. Now that was the theory part. Actually, I want to skip most of the theory part. Now, what is the difference between Pigletin and SQL? So the biggest difference with Pigletin and SQL is that SQL, a single query has to be executed. Most of your logic generally revolves around a single query. Okay. Most of your logic revolves around creating a single query, joining every table together, and then doing it. Instead, in case of Pigletin, you define the steps that first load my data, then transform into this form, then go to this label, and then do this. Okay. Similar to in SQL, the only way to break down your problem into multiple steps is by the way of creation of views. If you create the views on top of table, then that will be it. Okay, so SQL was designed for RDBMS, while your Pig Latin was designed for distributed computing. Okay, so Pig Latin can handle the unstructured data, semi-structured data, as well as structured data, while SQL doesn't. Right. So the main difference between Pig Latin and SQL is Pig Latin has been designed from bottom up to support for parallel processing and distributed computing, while SQL was designed for data operations using a single server, not using the multiple computers. All right. There are many use cases. Apart from that, there are many use cases of Pig. Biggest one is you can research on data. You can do a lot of ETL on top of data. The cleaning will be done using Pig mostly. Okay, cleaning of your data, reformatting and translation will be done using Pig. Right. So Pig basically lies somewhere between SQL and MapReduce. Right. All right. So there's a basic philosophy which Pig abides by. One is pig eats anything, pig lives everywhere, pigs are domestic animals, and then pigs fly. Pigs eat anything, as in data can be relational, nested, structured, semi-structured, it could be JSON format. So it can handle most of these things. Second is pig lives anywhere, meaning right now, as of today, pig has been supported on Hadoop, but the plan is to move to all other distributed systems. Pigs are domestic animals in the sense that they are well controllable and provide custom functions so that you can, there's something called UDF, so that you can control pig. In case it doesn't have those functions, you can create those, or if you don't like a function, you can just use your own function. Okay, now the D is probably the biggest reason. So D is probably the biggest reason why you would be using pig, the performance. So the biggest the USP which Pig provides you is the performance over SQL, because you decide how your data need to be processed. Okay. The easiest way to get started is just download a Pig zip and unzip it, and then set your Java home. After you have set your Java home, you can run Pig in a local mode, which means you can run it on your laptop even if you don't have Hadoop. Okay, it runs like a emulation of Hadoop, MapReduce. Okay, a local emulation of MapReduce. The same emulation which was used by MR unit is what is used here also. Okay, so Pig minus X local will do the job. All right. Now, once your local one is working, that means you are good to go. And now you can set your pig class path to the directory in which the Hadoop configuration is saved. And from there, it will read where is the name node, which one is data node, and so on. And then it will start talking to your Hadoop. Okay. All right. All right, so now you don't require big installation as such, because it is already installed on all the nodes, as you can see on our Ambari. The clients are installed on all the nodes, so we can basically say ssh hadoop 1 dot knowbigdata.com. All right, so there you can just say pig and it will get started. All right, now pig minus x local, you can see this. So there are two modes, as well as here you can see the pig as the client is installed on 4 nodes. Okay, all right. So you can simply SSH to any of the node and start working. So, okay. So most of the data is available into this folder called data, cd data, for today's exercise, and here it is. Okay. Great. Let's move on. So there's something called local mode, in which it only any file you are referring, you will be talking about local file, not the HDFS file. Okay. And it is generally good for using in the development mode, or during the development phase. The command line argument of pig are pig followed by the script name, whatever script you want to run. And the other argument is that you can execute a particular command. So let's see, if you run pig like this, it launches the console, and you can run commands like ls. Okay. Similarly, same command you can also run from the, and this ls, mind you, this ls is actually doing hdfs ls. Okay. So pig can be a very good way to actually, instead of using Hadoop fs commands, you can actually use pig. So you can see that we were able to execute ls command from the command line. Okay. And there are other arguments. Okay. So if you take each command which you are executing on pig, you put it in a file that becomes pig script, and you can run that script using pig followed by your script name. Okay. So now let's talk about the grunt. Grunt is this. So when you run pig, the command, the what do you say? The prompt is called grunt. Here, this is where you actually run your commands. Okay. You can run almost all the file system commands like ls pwd, and then you can say cat, and then say dot dot xyz, cat xyz. Okay. Or cat, let me say cat users dot csv. You can see this file users to csv here, and There you go. Good. Now you can change the directory to your folder. Here we are changing. So remember, when we are changing the directory, we are changing the directory in the HDFS. We are right now talking to HDFS via pig. Okay. So other than normal data queries, you can execute these nice simple basic commands which this provides. So anything which Hadoop FS provides, pig also provides you. Also, you can do kill a job in case you have run your jobs. You can kill the job from here. Okay, so you can say help, and here it will show you that you can kill a job using kill command. Okay, so these are the other arguments you might have a look at. So that is fine. Now the basic construction of pig script is each processing step results in new data set. Okay, when we load a file, when we do something, it results in a new data set. Okay, the ls command and others are just exceptions. These ls commands are basically not really part of the pig script. They are just provided by the console grunt pig command line to you, but they are not really part of the pigletting. Okay, so so things like load and other every okay, so pig minus x local, which runs in local mode, it doesn't connect to the Hadoop cluster. That one runs in dev environment. That one is only for the dev environment. Okay, so each step in a pig script, it generates a new set of data unless it's saving the data somewhere. Okay, or or dumping the data. So every processing step results in a new set. Pig is case insensitive. The only exception to the rule is the UDF or functions. Howsoever you define that, that is case sensitive. Okay. So okay. And then comments are multi-line comments, as in you can say like that. So is the data set overwritten? No, it generally gives an error. Now, let's have a very quick look at things. Very quick look, okay? Now, let's have a quick look at this particular file in HDFS. Okay, we say cat this. So, cat nyse underscore dividends. Okay, so we have this file. It basically contains the stock exchange name, the ticker name, or the whatever you want to call it, the ticker name, and the date and the value of each stock. Yeah, you can, yeah, ticker or symbol you can call it. Thank you, Sushant. What do we want is we want the average of each symbol. Like CPU, we want this much. Okay. So ideally in NSQL, we will simply say, those who are aware of SQL, we'll simply say select star from NYSE, select symbol and average of value from NYSE, group by symbol, right? So this is how we would do it in SQL. How would we do the same thing using pig? Okay, so the way any language is learnt is you show a program, then you walk through it, then you go into each each particular statement in detail. Okay, so you don't get overwhelmed by if you do not understand it right away. The idea is to give you an overview quickly and then go into the details of each step. Okay, so the easiest way to understand is that we loaded the data from here like this. Okay, so we say divs equals to load this particular file. Let's just say, and also you can give absolute path or relative path. Okay, okay, so let me, this thing is irritating, it's not copying this stuff properly. Okay, so let me just take this. Now, okay, yeah, you can do it from the terminal, but that one takes too long time and you will lose your patience. Okay, you can do it from the web browser from the hue, but you will lose your patience. Okay, right, good, good. So Abhinav is saying, so Abhinav, by default the data that pig loads is tab separated. Good point. Okay, now we are saying that load this data and say dump divs. Okay, no, all these things whenever, what is going on, input path does not exist. Okay, oh, sorry, I'm putting this way, actually this is wrong. When pig loads the file or data, does it keep in the memory? Good question, good question. Let me explain to you this. Okay, so when we are loading, we are not doing exact anything at all. We are just telling pig the divs means this particular file. All right, the moment we say dump divs, then it starts processing the previous steps and then it starts working. So pig does not load anything at all. Okay, so if you are in place of pig, say you are doing this whole exercise, you will basically convert this whole program into MapReduce and then execute it. Okay, and that's what it is trying to do. So it's only doing a definition. It's just understanding that you have written something. Okay. Then say group by, group your divs by a column called ticker. When we are saying load this data as these four columns, we can see that it has loaded the data. We can also say explain us what is divs. Okay. So it says that, or we can say describe divs to see what data type it has. It says that your divs is name, ticker, date, and value, and all of them is a byte array. Okay, by default, everything is a byte array. Now, what we are saying, we group our divs by a column called ticker. Right now, the data is grouped. So after we do grouping, then we do generate the average value. We have generated the average value. Now, if you see, these each steps is not taking time, which is a very important point. It's not doing really anything. It's just making a note of that what is grouped, what is averaged, what is divs, and so on. And the moment you try to dump the data, it will start processing. Okay. Now let's say store my data to this particular file. It says file already exists. We say average 24 gen. Now it has started the process of, now it has kicked in the process. Okay. Now store basically saves the data into some file. All right. So yeah, dump divs means line by line processing, same as map reduce. Yeah. Dump means just print the data whatever is there. So this was a quick overview of how does it work. Let's move on to each step what we talked about, and we'll start again the description of each and everything. Okay, so first of all, so that was a quick, a very rash description of the language. Now let's go into the details. There are something called data types, and there are two kinds of data types. First is the scalar, the basic one, int, long, float, double, char array, byte array. And second is the complex ones. A complex ones is something new to most of us, which was not there in any of the RDBMS. Okay, the complex ones such as map, tuple, bag. A map is basically like a key value pair, a collection of key value pairs. The key can be a string, while the value can be any other data structure. Okay, another the value can be another complex type. It can be a tuple, it can be something else. All right. So the way it is represented in the when pig is reading the data from file in this format, it will be expecting the data to be formatted by default. Okay. All right. Similarly, we have something called tuple. Tuple is analogous to a row in the database. Tuple is very analogous to a row of a table. Okay. And bag is analogous to collection of rows. Okay. Bag is nothing but a bag of tuples. Okay. So a tuple is a fixed length ordered collection. Okay. We know how many columns are there, in what order are they. We can refer to each value either by the column name, or we can refer to each value by saying column 1, column 2, column 3. Okay, right? So the way it is represented physically, as in when we are loading data from file system, pig will expect the data in this format. Okay, a round bracket and saying this way. Okay. The important part you need to note is that a tuple doesn't need to have of all the values of same data type. One could be string, other could be integer, and third one could be boolean, and fourth one could be another complex type. Fourth one could be another map. All right. And bag is represented as curly brackets and separate and tuples separated by comma. Okay, so bag is a set of tuples. A bag is a set of or a collection of tuples or rows. Bag is very analogous to a data set or a table. So you hope you understand the difference between map and a bag. So map is in classic sense a collection of key value pairs, while bag is a collection of rows. Okay. The quality of a bag is in case it doesn't fit into memory, it spills over to the disk. Okay. While a tuple has to be loaded fully into the memory. So there is no defined limitation by pig with respect to the size of data. It will be up to how much Hadoop can handle. All right. Other is pig is not very particular about schemas. Either you can tell it upfront in the format like this. Okay. So a schema is when we define the data type of the values. Okay. So we define what are the data types in pig. We have int, long, float, double, char array, byte array. Char array is a string, byte array is basically the most raw format of the data. Okay. Schemas in not very particular about schema. You can either tell it upfront, like here we could also say load my dividend, where exchange is of type char array, while symbol is of type char array, or we could just skip the data type the way we did when we are running the example, right? When we were running the example, we did not care about data type. Okay, now it is done whatever we had tried to run, it has done fairly. All right, you got it. All right, so we have good. So most of the way when you're trying to compute average or some values, it will try to convert the data into that particular data type. Just like most of the loosely typed languages do, they try to guess the data type based on the situation. Pig also tries the same thing. Okay. And also, when you are defining the complex data type, you can say for example, here we could say a colon map and then square brackets. And even what is the value type in map? Remember that the the key of a map was always a string, while the value could be an integer, right? Or could be a complex type, could be double, could be long, could be string, could be byte array, could be uh, a, a tuple, could be any other data type, right? Therefore you can put inside here um, saying you can here say that my data type is char array. Okay. Or you could say my data type of map is tuple. Okay, tuple, and so on. So the this the idea. So we could actually declare the complex type to any level while loading the data or storing the data, and we can define as we say that pig eats anything. This is exactly what it means. It can handle. We can define the column names, or we can completely skip. Even we can say dividend equals to load NYSE dividends. Okay, we can say this like this. Okay. without telling that how many columns are there. And once it loads it, we can refer to each column as $1, $0, $1, and so on. All right. So this is, hope this is clear to you. We can define a tuple like this. We can say a particular column is a tuple. A column tuple as in it contains two columns, it contains three columns, or we can say the value of my map is this. Okay. Value of my map is this. We can also say value of my map is this. Okay. So we can define it that way. And you can, and whenever you want to change from one data type to another. Also, in case of bag, when we are defining the data type, in case of tuple, you have to define, you can skip the column definition altogether, or you can tell the column names, or you can tell the data type of each column as well. All right. So is it smart enough to decide the data types for undefined fields while loading? Yes. It is actually better to define the data types sometimes. Okay. So that also it would not make too much of a difference for pig to basically, you know, whether you define it upfront or later. The only thing is you are a little bit assisting in optimization if you're defining the data type upfront. So by default, the data type of everything is byte array. Okay. And on the circumstances, pig tries to guess the data type of various fields. All right. Let's take a break of 10 minutes. Okay. Hi, I'm back. Are you guys back? Great, great. All right. So we talked about the data types in case of pig, the complex one and the scalar one. And then we talked about the schema definition. And remember that the pig is basically a sort of a query language. It is not like an SQL, which also provides you insert into or update. Those kind of operations are not there in pig yet. All right. Now, the next step what I would like to describe you is something called load. So when we want to load a file from HDFS or load the data, this is the first step in case of in case of any data loading exercise. You first load the data, then you start doing operations. So if you do not specify the columns, it guesses the data types and uses the tabs as the separator. It can be the name of the URL, this particular one. It understand that it is trying to load that HDFS file. It can be a relative URL or it could be an absolute one. Okay. And everything will be on HDFS. Okay. It will be in HDFS. Unless you are running in pig minus x local. If you are running pig in minus x local mode, then it will be thinking that this file exists in the local file system rather than HDFS. Now, it will look for this file in local file system if you are running in local mode. Now, when you can also load the data which is separated by comma rather than tab, say comma separated values, using this syntax. So we say use pig storage and comma is the separator. Okay, so this way you can load the comma separated data into your divs. Okay, similarly, when we are storing the data back, we can also say at the same time saying use pig storage and our separator is comma, right? That way we can save the data back in the comma separated format, right? Other thing is that when loading the data, we can load multiple files together into divs. Okay. The only thing is the each row in the data can be in different format, and you have to be cautious while you are applying your functions on that data. So this is a wildcard character, not the regular expression. Okay. The other format is we can load the data from a table called NYSE dividends from an H-based database, right? As we talked about, the database which PIC provides a data store, not really a database, a data store which Hadoop provides us is H-base. So if your data is lying in H-base, then you can load that into pig using HBase storage. Okay, so there are multiple kinds of storage which are available. You can also load a data using JSON format, and then in those cases you will specify that you are using JSON storage. Okay, there are various projects available which provides you the JSON storage. Okay, let me just make a note. So we don't have right now, but I'll see if I can do that. All right. So, and then you can define the data type of each column and so on. Sounds good? Sounds good. Now, next step is to understand what goes on. Let's just keep our dividends ready. Dump dividends. Does it say file not found? No, I think it found the file. And you can see that this is actually the map reduce and everything running here. You can take this URL and track the job just like we were tracking our map reduce job. All right, so it has loaded and we have printed the data, right? And explain will tell you that what is going on with this data set. Okay, it tells you that the map plan is dividends is basically a pig storage file and we are loading from there. Okay, and the file is located here and so on. And there are various details you can get from here. Okay, if it's a complex one you will be able to understand it better. Okay. All right, so you can use describe also just to quickly peek into the data type. Right now, since it doesn't have, we haven't defined any data type for this, it is telling us, but in case we load the data type in the following manner, it will show us, we can say describe divs, and we can see that the data type of this one is this. All right. Specifically, after churning a little bit of data, say group by for each, you would need to understand your data type of the data set. All right, so you can use describe to understand the schema of your data set, and then you can explain on a data set to see the detailed analysis of the query. All right. If you are very inclined, you can go for a syntax highlighting tool, which is mentioned here. The next one, that simplest one, is store. The syntax of store is probably very simple. Okay, exactly similar to our load. It's just that instead of loading the data, it stores the data. The only difference between store or and dump basically prints the data back onto the screen. And in case you want to, I mean, you want to redirect the std out to a file that you can use dump in that case. In circumstances, if you want to dump some data set and you want to store it as such, you can use redirection of the file system by running this script as running all these commands in a script and then redirecting output. Okay, so that is one idea. The most important aspect of store or dump is that these things, both of them, store as well as dump, they force pig to start execution. The moment you say store or the moment you say dump, pig starts working. Before that, it was just making the note of what you were trying to say, right? Unless and until you say store or dump, nothing would start. it will just keep on making notes that, hey, you want to load that file, then you want to group on that file, and so on, right? Also, the other important aspect of a store and dump command is that they don't generate a new data set. Okay, they don't generate the new data set. Good. Now, if you have to iterate over a data set, you can use for each. Okay, so for each essentially is like a map where we are given an input data and we are converting into some other form, right? So you can see that we loaded the data like this, and then we said, all right, now you can say dump values. So for each, what it does is it for each data set, then we say generate, and then we pick one of the columns out of this data set. Okay, we pick ticker value out of these data set, or maybe we can apply function like sqrt or other function. I'll show you those things. Also, you can say one comma here like this. So basically you can project your input into new format. Okay, and this is what for each does. Okay, now it did not find the file path. Okay, did I make any mistake over here? Dividends, right? Is that correct? And why SC dividends? Oh, can we say from examples divs and values are formatted tables? You can think of divs like a table, right? Okay, so when we dump, it doesn't store anywhere, it just dumps onto the screen. But if you say store, the file is going to be stored onto the file system, which is HDFS. So here, when we say stores, it basically stores the data by default onto HDFS. In case we are using some other HBase storage, then it will be storing into the HBase. Yes. So values, which values are we talking about here? So yeah, values is, yes. Again, values is another table. Yeah, you can think of it like a table. You can see that, and we can say dump values. Now the whole process of map and reduce is going to start again. Okay, this load will happen, then this will run, and then this will happen. Okay, it's not that since we have done dump here again, that does not mean that we are caching. This will not cache the data. Okay, the moment, even if you have dump here and then again dump values, both this and this will happen again. All right, so we are basically trying to see, you can see that we are left with only two columns in this one. All right, a little bit more details about projections. For each is generally used for projections. Projections is selecting which column to go in the output, or whether we want to modify the values of columns. Okay, so we can say things like a mathematical operations such as addition, subtraction. So what does generate do exactly? The generate do, what does generate do exactly? Generates is equal to this. Okay, so whenever we say select x comma y comma z, this is what we are saying projections. Okay, so this is what generate do exactly. So we go record by record and then we say generate this. Okay, so what it is going to do is for each row in the, for each what do you call, each tuple, for each tuple in a data set called prices, it is going to execute this close minus open. There would be a field called close and there will be a field called open, and we would subtract those. Similarly here, so in case you did not give any name, or even if you have given a name, you can talk to the system using using column numbers. Okay, 1 2 3 4 5 6 7. What, so it starts with the 0 here, 0 1 2 3 4 5 6 and so on. All right, so the it is zero based index of the columns. So what will it generate? It will subtract the two values and then it will generate the output. It will be generating only a single column which will contain these. All right. Is there any exception error generated if data type doesn't match for generate? Meaning, in case we are trying to say subtract one string from another, then it will give an error. If it is not able to subtract two values, then it is going to give an error. All right. Now, similarly, if you want to select the columns saying everything up to open, then you say dot dot open, and then it will generate only the column, first four columns. If you want to generate all the columns from one column name to another, we say open till close. Okay, and if you want to generate all the, basically all the columns after a particular column, then we can use dot dot like this. Okay, and we can apply various functions on top of it. So as you can see that for each essentially is like your map reduce. Okay, and it is not really doing anything other than translating data from one form to another. It doesn't, basically it doesn't do any aggregation. All right, so will it have any reducer code generated? Anybody? No. The answer is no. See, the for each, whenever we are doing for each, it's basically iterating over the data. That's all. It's not really doing any group by kind of thing. It's not doing any aggregation. So in these circumstances, there will be no reducer code generated, right? We are not doing any aggregation. All right. Now, if you don't believe me, then let's have this. Okay. So here, if you look at closely what's going on, and pick up one of the things here. So it says there is a mapper. Okay, there are two mappers actually. Okay, price and gain. It's a screen blindness. Okay, yeah. So there is a mapper, but it says there is no combiner or there is no reducer, right? You can see that. Also, there will be more details into this. Here, you can look at the job ID, what's going on with the job ID. And there it says that there are 0 reduces and there are 1 maps, right? So I understood the question as, does it generate some data? Okay, all right. So it doesn't produce any reducer code because there is no aggregation involved. The everything finishes off onto the map side itself. All right. Now again onto the for each. Again onto the for each. So with respect to the complex data types. So when we are, let me have show you a little bit about something called, we call it cat baseball. Okay. So as you can see, let's pick one of the values from the data set. You can have a look at this. So all right, we have this. As you can see that this basically contains the name. These are baseball data from one of the examples. So the name of the player, the name of the team, and the name of the team, then name of the trades, as in what all it has played. And here it is essentially a bag of tuple. This tuple contains only one column. Okay, this tuple contains only one column. Okay, and then you have a hash map of various history of the player. Okay, the betting history of the player. So that it's a hash map, I mean the map, like this. It says total number of games played by this player is 297, hit by pitch is 5, on base percentage is this much, grand slams are this much, and so on. Okay, while this player seems to be a newer than this player, total number of games played by him is 64. Right now, in case you want to just extract total number of games played by a particular player, all you need to do is, so you loaded like this, right here, and all you want is to find out the batting average, for example. So you can say something like this, or in case you want to say that all we are interested is in in the number of games each player has played. Okay, in those case we'll say name comma this. Okay, all right, and we want to say games count. Okay, I can say, so this way you can iterate over a data set which is of complex types, which contains the complex data columns, right? Sounds good. Okay, so Abhinav's question, as you can see that the batting average we have computed, see the 64, and the last example which you use was how much? Number of games played is 297. Yeah, so 297. Yeah, so we are doing something good. So we are able to extract the data from a complex structure, right? So you basically can, in case you are talking about tuple, you can refer the each value of a tuple like t dot x, and in case you are doing a bag, in case you have bags and you want to, out of the bag you want to just print out first column only, then you can use this. If you are using, right, you can also say, instead of, if you have a bag containing these tuples, so you can generate new set of bag containing only the two columns of projection instead of all three columns. Okay, right. So tuple dot 1 is 0 and 1, meaning y. Okay, so basically what we are trying to do here, the way what we did here, you noted that here we basically said print the values from this hash table, I mean which is map, extract all the values of a key called batting average, right? In our case we just displayed games number of, so we are referring to a particular key in this map here, right? We could also say here like bat hash games and so on, comma, then we could say a lot of things, right? So this way we are able to transform the input data into various format we want. Similarly, in case our input is a tuple, input is described as a tuple, I mean input is a bag of tuples. So here t is my bag, t is my tuple containing x and y, right? In those cases, I can only print these two columns. I can say only this, or I can say to the same one I can refer to $0, which means it will print the x value twice, right? Can you hear me clearly? Good, good, good. All right. So if you have a bag input, if our input data type is a bag, one particular column called B, our bth column is a bag, say here traits is a bag, and we just want to refer to one of the values. It's a bag of, it's a table. B column is a table. B column itself is a table of two columns x and y. Okay, the bth column in the input is a table in itself containing two columns x and y and multiple rows. So, and we can basically generate only the first column out of, you can extract out only the first column out of this bag and print it into the output. This is what it does, right? So our input was, where did we go? This is our base ball. Let's say describe b ball, and we have traits, and we want to say t equals for each b ball generate traits dot dollar one, right? Dump t, right? All right. So it doesn't have something called dollar one because it has only one columns, as we saw in our data set. Where did we put the data set actually? Yeah, here there is only one column, therefore the other it was empty, right? So we are trying to refer from this only one particular column. Also note that inside a bag we cannot refer to one particular row. Yeah, even if the column did not exist, it went on. Okay, because the whole idea about pig is being able to eat anything. It says the one of the philosophies. So imagine that you had two rows. One contained the second column, while the so imagine that there are two rows, and the second column of this row is a bag, and in one of the values the second column exists, and in another the second column does not exist, right? So in those cases it will work well, right? Now you can see that. So it basically left that particular column as a map itself, as a bag itself, but kept only one column, which anyway it did not make much of a difference. Also note that it is difficult to select one part of a one row, one tuple out of the whole set. Okay, that kind of thing is not possible What if we included the tuple column types? Yeah, still, it would not give you an error in case one particular tuple, one particular column doesn't exist in tuple. Because because in our data set, it is not guaranteed that all of the columns will exist. That is the basic premise of having a semi-structured data. All right. So you can see that we were able to handle the complex type, and we were able to pick and choose the values from a complex data type. Furthermore, we can I'm sorry. Furthermore, we can, you know, do simple mathematical operations such as dividend into 100, and then we can give them a new column names. Okay. If we don't give them any column name, it doesn't have a column name, and we'll have to refer it by the indexes, and so on. All right. Now, while generating the data, you can apply various functions on top of it. Like, for example, these are the list of various functions which are provided by Pig to you. Say, for example, all the mathematical operations are there. So you could say that for each my data generate something like sine of x into sine of x plus cosine of y into something of that sort, and so on. Okay. And then we can say, although its value is going to be always 1, but still, if this is x and y are equal, so you can generate. And if you want to give it a column name, you can say like this. All right. So there are many functions you can go through it, and these functions are pretty straightforward. There are datetime functions. There are, okay, and there are these functions also which might interest you. Is you can convert your data type from one form to another. So we just converted our each row into each tuple. Similarly, from a tuple to a bag, you can convert it this way. All right. All right. So if you want to generate a map out of a bag, you can do that easily. As you can see here, to map, we are iterating over values and then putting that. You can do that. So these are the various functions provided by Pig to you. So most of your requirements will be catered by this. Now the next one is the filter expression of Pig. Filter should not be difficult because it is like a where clause. Okay. So whenever we are iterating over the result set, we can say that give me only part of the result set which matches this particular condition. Okay. So say for example, you have loaded NYSE dividends into divs, and on divs we say filter divs by this condition. Okay. So Whenever this condition is true, the record is going to be printed in the output. In case this condition is not true, that record will be skipped. So if symbol matches this, then it will go into the output. If the symbol does not match this, it doesn't go into the output. All right. And note that it is not a wildcard. It is a regular expression. So all of you have been acquainted with the regular expression. Have you gone through the session on regex? Good, good. So basically, what does this mean? Can somebody tell me? No, the whole expression. What does what should this result ideally? This whole condition. Find. Okay. Let me do that as we are talking. So we loaded divs. Now we are saying good, good. Find all the matches starts with CM followed by anything. Perfect. Anything that starts with CM, first two characters are CM, CM and then perfect. Great. So so basically we want to see only the values of all the symbols whose name starts with CM. All right. Let me just mute my chat. All right. So this way, see, we got only the rows. You can see CME, CMP, CMU, CMK, and so on. Right. So this is clear to you. And here, if you place not before the condition, this whole condition will get negated and so on. So this is not of the previous condition. Similarly, while applying filter condition, you can also say things like this: dividend greater than zero point 0.1 and dividends less than 0.12 and so on. Okay. And more operators, you can have a look here. It's a comprehensive list of all the operators. Okay. They are Boolean operators. Okay. And or in, not, and so on. Okay. Now, yes, you're not using filter. We cannot add column name to see selected columns. No, I did not get your question, Susant. Can we add column name to see selected columns to filter? So no, you can only filter by rows. It doesn't filter the columns. That part is taken care by projections, which is for each. All right. So for each is more like a column wise operation, and while filter is like a row wise operation. If you want some rows to go in the output, some rows don't, you apply filter. If you want some columns to go in the output, some columns do not, or we want to change that, then we can use projection, which is for each. Okay. No, you can't do that. So the syntax is filter and yeah, I saw that. Yeah. So you can't do that. You can't add more columns in the output. So you can think of it like a where clause from here till here. Okay. So you can think of this the select star from something where something is broken into two parts. Select star from table has become for each, while where clause has become filter. And here I'm talking about the database. I mean, I'm trying to compare the database with the pig. Sounds good to you? No? All right. So have a look at more complex operations which are available into this URL. Okay. And also here is the JSON storage. You can load the data. You can load the JSON data using JSON storage. Okay. Now, again, same question. Will there be any reducer code generated? Anyone? Right. Since there is no aggregation happening, there will be no reducer code generated. So filter is clear to everybody. Now let's move on to order by. So first, what we discussed was we loaded the data. Then we discussed how do we iterate and select only few columns out of the input. Then we talked about how do we remove certain rows. How do we only keep certain rows out of the data using filter command. And now we want to order our data using a particular field. Okay, so we say order our divs by a symbol. Okay, by one particular column, then another column, and so on. By default, the ordering is ascending. By default, the ordering is ascending. If you want to have descending ordering, you can put DESC in front of the column names, right? So order by is pretty straightforward. You can order by more than one columns. Say for example, for two records, there is a same symbol, then we want to order it by dividends and so on. All right. Yeah, priority is from left to right. First order by symbol, then order by dividend, and so on. Similarly, distinct. If you want to find all distinct values, say for example, we want to find out what are the various symbols available in this input. So first, we'll just load the data. All right. We loaded the data. Next thing we would do is we generate a symbol. So if you see, symbols will contain now, symbols will contain only the list of the column called symbols. If we want to find out only the unique ones, we could do, let it finish, and then we can dump the unique symbols, right? This is clear. So order by distinct. Now question to you is, will this generate any reducer code? Yes, this will generate reducer code. Why? Because we want to sort it because of the distinct. Yes. So you can see that it contains all these values, even the duplicate values. And now we said unique symbols. Let's just print unique symbols. Now again the whole process will start, and let's have a look at what's going on with this. You can see here this time. Good. Now you can see there is one map and one reduce, right? These are the distinct symbols or distinct tickers, you can say. Good. Now the next stage is why there was only one map. Yeah, because it combined all of them together. Whatever logic you did here, it did a lot of optimization. So his question, okay, let me rephrase his question. When there is something called load and then there is for each, why was there only one map? Why? Because it combined all of them together and then running it. Also the data input is quite small. Here one map means there is only one map task which is going to get executed. Okay. There is only one map task which is going to get executed. Yeah. So, okay. Sushant's question is, did distinct did not aggregate symbols, it just removed duplicates. So how it's generated reduces reducer code. He's confused. Okay. So so had you been doing this, you will basically write your code such that there is a reducer and reducer will be removing the duplicates, right? Reducer will be given a key and all the values, and then you will be having removing the value and leaving only the key in the output, right? So therefore, yes, it will has to group to remove the duplicates. So so basically when you have standard map reduce in place, then you'll of course will have the reducer code in place. Sushant, are you still confused? Because distinct cannot happen by just running only the code on the on each of the node. You have to aggregate and reduce. Distinct does not give, but imagine this. I mean, how should I explain to you this? So if there were three maps running on these three maps, somebody has to aggregate and then again deduplicate, right? So when I say reducer code, it means that is there a phase in MapReduce which, i- okay, so is there a phase which is doing, uh, the removal of the duplicates? Is the sorting happening? Okay, let me say this way: is the sorting happening? Right? Good. Again, distinct symbols. Yes. All right. Now moving on to join. Should I move on to join? Do you have any questions? All right. Good. Good. So join would be probably one of the reasons why you would like to use pig over your MapReduce, because in MapReduce it's actually a big pain to do joining, right? You have to figure out that if you remember our fourth question's solution, it is actually quite tricky. Now, to make our life simple, Pig has come up with a very decent jo- syntax for joining, and I'll show you this. So if you want to join two tables together on a particular key, you can do it this way. You loaded NYSE daily, you loaded NYSE dividends, and then you join these. And join syntax is like join daily on particular column. Note that column, okay? Join on a particular column and then join with another data set called divs on another column. So it will result in the data set which is basically basically will have these columns, these columns plus these columns, okay, and all those rows will be together from this side and this side where the symbol matches, symbol 1 and symbol is matching, okay. So let's say that you have NEC daily and we call it, so we have an NYSE daily. It has, let's say it has only two columns, these many. So if it has symbol A and date is 1 and symbol B and date is 2, and if there is another table called NYSE daily like this, and let's say it also has something called, let's just assume for time being it has these columns, okay. So it has A symbol and 1, let's say this is 12, and then we have db point for 2 and so on. So if we are joining these two together on join on here a symbol and here symbol 1, what we'll get is this. What we'll get is, for this one there will be only one row, and then there'll be A, and then there'll be 12, and then there'll be point 2, okay. So let's just try to do that and try to see how many columns are there. Describe. Okay. So you can see that there are all these columns and their names are in this format, right? Dataset colon colon the column name. Okay. So that is your output after the joining. In case you don't want some columns, you can say for each and then remove those columns from the output. So you can say JND. Yeah. So if you can see, it has put the dataset colon colon as the qualifier. So that's how it avoids that confusion, right? As you can see here, the data set is generated. Let's here you can see the data set it generated is this. Data set it generated is this. You can see daily and divs, right? Good. Now, if you have to join on multiple columns together, okay, say you want to join on exchange as well as symbol, where exchange of one is equal to the exchange of the second one as well as the symbol is equal to the another one. If you want to do that, you can use this kind of a syntax. Can use this kind of a syntax, right? Now, something you need to understand is that there is no such thing called self join when it comes to pig. Okay, what you need to do in case you are trying to do a self join, you will have to load the same data twice and then join the two data sets. Okay, you cannot have something like join divs by symbol comma divs by symbol 2 some other column. You cannot do that. You'll have to load it twice. Now there are differences from the standard RDBMS. If you notice the differences, first one is there has to be at least one column for joining. You cannot have something like select star from A comma B, which by default means join it and multiply all the rows, right? The cross section, that's not something which happens here. Second, the join cannot have the conditions. For example, this join A B on A dot value greater than B dot value. Can somebody tell me why are these two constraints? Why is it not possible? Anyone? Because of unstructured data. Okay. Think about it. If you had to, how would you actually join using MapReduce? How did you join in the first session, the fourth question, when we're trying to join the two tables, how did we join? Common data, right? We basically, the column which we are trying to join the two tables, we make that as the key, and it is mandatory to have some sort of a key, right? Therefore, we should have at least one column on which we are joining two tables, right? Cartesian join is not possible this way. Now, and the same reasoning applies for the conditional joins, as in a dot value greater than b dot value. This kind of joins are not possible using pig, and it is going to be really difficult to actually get this thing done. If we want to generate the output such that a dot value is greater than b dot value, it is going to be very difficult. Even with MapReduce, think about all the ways you can actually do it. You get my point? Because this would not lead to any common key for the MapReduce phase. If you have to do it using MapReduce, it'll be very difficult to do such kind of thing, right? So this kind of conditional joins are pretty difficult. The only thing you could do is you generate all possible combinations using cross join and then eliminate all those rows which do not fit to your condition. I'll show you that part. So here is a little bit diagrammatic representation of joins. So you have a table A and a table B. A, A has, or let's say A is a data set containing two columns, ID and name, and B also has ID and name. When we are joining A and B on ID, then this is what we get. Why? Because 3 is not there on the left hand side and 2 is not there on the right hand side. Therefore, we only get the first row because ID1 and ID1, right? This is what we get. Now, there is something called left join. If you want to join, if you if you want the values from the left hand side to appear irrespective of whether the value exists on the right hand side or not, then we use the left join. So there are two ways to do it, two ways to write it. Either we can say join A by ID and left outer and B by ID. Okay. So basically we write this keyword in the middle of the two two sets which we are joining. We are writing in the middle of it. Between A and B, we are doing left join, right? So we are saying whether the value exists on the right side or not, print the value from the left hand side. So to Ryan does not have a corresponding value on the right hand side, still it gets into the output. This is called left join. We can write left outer or left join. The keyword comes before the comma, okay, between the two sets which we are trying to join, A by ID and B by ID, we put left in between, right? Left means we want the output from the left hand side in the mandatorily we want it in the output. Now the next one is the right outer join. We want the values from the right hand side, where irrespective of whether it exists on the left or not. Although it was not really too much required to have the right outer join. Why? Because we could always say join B by ID and then left comma A by ID, right? We could just swap the two, right? So this is what is called right outer join or right join. Then we have full join. Full join means values from the left and the right, they come together, okay? Even if there is no data corresponding to both on the both sides. So you can see 2 Ryan and 3 Saha has appeared in the output even though there was no corresponding values on either sides. That is called full join. Right plus left, that is full join. Okay. Okay. So a quick question to you. A quick question to you. Simple join A by ID and B by ID gives us n1 rows. Okay. Now join A by ID and left gives us n2 rows. Okay. And this one gives us n3 rows. Okay. So how many rows will full give? How many rows? Anybody? Or records, let's call it records. Right? Interesting, yeah. So Seema is right, Swati is right, Sushant is right. Good, good, good. Yes, that's correct. So that means you have understood what does it mean by full join and what does it mean by left and right and normal join. Okay. This is the normal join is generally called inner join. Okay. And left and right are outer joins. Left, right, and full are outer joins. Okay. Now few teasers. So if you join A and B like this, what will be the output? Quickly, anyone? Are you sure? Remember the syntax? I was telling you the syntax? No. Actually, it's error. That's why I called it a teaser rather than a question. Why? Because the left outer has to be in between. But your attempts were right. So Ranjit was correct. Good. Now let's go ahead. And what about this one? Yes, syntax error. Good, you got me this time. Now the other things which are important is one is limit. So if we want only 10 records, we can say limit my input to this one. So limit divs 10 gives you only these records, first 10 records. Okay. So you can see where is the so can we have last 10 or middle 10 with limits? I think you can have it. I think by putting minus 10 in the output, you can actually have. That's exactly what I was looking for. Okay, I'll have a look at it. I'll let you know next time. Let me make a note of it rather than wasting time now. Okay. Now, yeah. So for time being, the other thing is the sample, which is something which is not there in 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 our standard one. Uh, Sample basically it's something is interesting thing when it comes to big data that I mean if you the moment you start churning humongous data, you will realize that you need a sample of it. Okay. Now you need a smaller data to work upon. Now one way to get the smaller data is by using limit that will give you only few records, but these records can be very skewed in terms of these records may not give you the correct picture of your input. Therefore, it makes sense to randomize a sample. One record from the beginning, second record from midway somewhere, third record from midway somewhere, and fourth record from the end. So that is sampling. Your input, the data generated by sample will be randomly picked up from the input set. So whenever you are dealing with a humongous data, you generally work on a sample, and this sample should be fairly random sample. It should not be from the beginning, from the middle, from somewhere. No. Okay. And also note that sample is not fast. Like limit is pretty fast because you just have to pick up first 10 records and return. Sample is fairly slow process. Okay. It has to go through the whole file again. So we say sample divs and a ratio. This means 0.1 means 10%. 1/10 of the total data is what you get. Okay. Now first question to you is this. This is something which we all make mistakes. So will this give these two statements give the identical results, or will they give the same result? Will they give different results? If you run dump data twice, will it give the same output? Why? But if you see, we are just dumping the same data sets, right? Good. No, the okay. Sampling is random. So sum is a random set. Now my question to you, I'm trying to trick you guys. I'm trying to figure out whether you understood the phenomena or not. So dump sum. I'm dumping the same data set. So do you think it will be different or same? Does anybody change his opinion? Yes, you are right. Good, 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 good. Yes. So all of you have understood the question correctly, and yes, so it will be different because every time you dump, only then the whole process of map reduce will start again. So first dump will start the whole sampling process, and then again if you dump, it will not cache the data, it will again start the sampling process. You can see this. Do I have so let's say I want to, right? No, I should have done 0.05 instead of doing this. Right? So you try to experiment with this. The answer is that it will not give the same results. It will be different. Okay, that's a very quick answer. Okay, now, all right. So we will take from here onwards in the next session. There is quite a much of it is remaining. Now, rest of the pig session is about various newer syntaxes which are not there in earlier. Okay, we'll talk about group by, we'll talk about other aspects. All right, so start attempting the pigs quiz which is there in the LMS. Okay, okay, nice, good. So we'll see you tomorrow and have a good day. Thank you. Thank you, Sushant. I'm happy that the class is good. Everybody, most of you are understanding it. Great. Have a good day. Bye bye.